And finally, in our last part of section 6.6, we're going to solve exponential equations that are quadratic in form. So the key to this is these are kind of just the miscellaneous ones. So example 11, we have 3 to the 2x minus 3 to the x minus 12 is equal to 0. So when I look at this, what I'm going to see is, first of all, it does have 3 terms, which we haven't done any other one in the exponential set that has had 3 terms. So that's kind of a clue. The other clue is that we're going to notice that the middle term has an exponent that is half of the first term's exponent. So this guy is half of this. So that also tells me what else to do. So we're going to come in and we're going to let u equal 3 to the x. And if I do that, and I square both sides of that, I get 3 to the x squared. And when you raise a power to a power, you multiply, that becomes 3 to the 2x. So we'll substitute in. So this is u squared minus u minus 12 is equal to 0. Now we have a quadratic. And they'll factor. If not, again, take it to the quadratic formula. But this one factors. Factors into u minus 4 and u plus 3. So u equals 4 and u equals a negative 3. So that means now we'll unsubstitute. Sorry, 3 to the x is equal to 4 and 3 to the x is equal to a negative 3. Okay, now I need to solve each of those. So again, the substitution just got me to the point where I could then have 2 single equations, right, that we can solve. And we'll solve these by taking the natural log of both sides. So this would be the natural log of 3 to the x equals the natural log of 4. So that would be x natural log of 3 equals the natural log of 4. Or x is natural log of 4 all over the natural log of 3. So that one's beautiful. This one, however, we have an issue. So think about this before we go to the natural log. Doesn't matter where I recognize it. I need to recognize it somewhere. This is saying that I have a positive base of 3. I'm going to raise it to some exponent. And when I'm done with that, I'm going to end up with a negative. Well, how can I take a positive base, raise it to an x, and end up with a negative 3? I can't. So this one's going to be a no solution. Now, notice if you went further, you'd end up with x natural log of 3 equals natural log of negative 3. You can't take the log of a negative, so that's why it's no good also. So from either point of view, you should be able to recognize that that one does not work. Okay, next. Our last example. Let me get my number written at the top, did I? So this is part 4. Okay, the last one, example 12, says we have 9 to the x minus 3 to the x plus 1 minus 4 is equal to 0. So when I look at that, I say, okay, I still see the 3 terms, but I don't have the middle exponent being half of the first. So I have to do some rearranging first. The first thing we're going to recognize is that 9 is 3 squared. So that becomes 3 to the 2x. This guy's a little more complicated. We're just going to split it apart into 3 times 3 to the x. Now, backtrack that to make sure that makes sense. If you multiply the bases, don't we add their exponents? So if I take this times this, I get the 1 plus x, which is sitting up here. I wrote the 3 out in front. You'll see why in a minute. Minus the 4 is equal to 0. Well, that's just 3 to the 2x minus 3 times 3 to the x. That's a times. Minus 4 equals 0. Now we'll substitute. So again, we're going to let u equal 3 to the x. So this would be u squared minus this 3 is going to stay as a coefficient. We're just replacing the 3 to the x. And that's why I wrote the 3 to the first power in front, because of that. Now we'll factor. We've got a quadratic. U minus 4, u plus 1. So u equals 4 and u equals a negative 1. And then you have to unsubstitute. So 3 to the x equals 4. 3 to the x equals a negative 1. This one won't work because you can't take a positive base and end up with a negative answer. So we'll take the log of both sides on this guy. So that'll give me the natural log of 3 to the x equals natural log of 4. So x natural log of 3 equals natural log of 4. This is identical to what we did in the last one. So we end up with the natural log of 4 all over the natural log of 3, and there's our solution. So I think the quadratic and form problems are kind of interesting because we did this clear back in the very, section 1.4. So we've done substitution before, but definitely not of something that looks like this. And that wraps up section 6.6. Our last 2 sections are applications of exponential and logarithmic equations. So